ऐसा कहा जाता है कि किसी काम को यदि लगातार 21 दिन किया जाए 21 डेज तो उसकी आदत लग जाती है। हैबिट या आदत जो है वो अच्छी भी हो सकती है, गुड हैबिट, और वो बुरी भी हो सकती है, बैड हैबिट। गुड हैबिट में मैथमेटिक्स जो है जो हम कर रहे हैं, लगभग इतने दिन हो गए। मैथमेटिक्स needs a lot of practice, and if we have the practice with the extreme limits, then you will enjoy mathematics. If you people are interested to do mathematics, then practice is must. Go through the basic concepts again and again. Practice the solved examples as well as the unsolved problems, and think in multi-direction. So dear students, good morning to all. I hope you all are well. We are doing vector spaces. We took the examples in different ways, but today we will consider two examples. First, we will solve in the class, and second, you will try yourself. This is different one that we have discussed before. Okay, so let us begin. The first is, let V be the set of all real valued functions. Several times I have told you, and again I am telling you just now, go through the question properly and find what is given and what is to be calculated. Go through term by term, not just like the newspaper. Underline that particular word which you know that and which you do not know. Okay, so let us see. V be the set. Which type of set? All real valued functions defined on R. What is the meaning all real valued functions defined on R? We will discuss this with the standard operations. Now here the word standard operations be given, so you must remember what is the standard operation. That means standard addition in functions and standard scalar multiplications in functions. We took the examples of matrices previously. We took the examples of ordered pair previously. We took the example of triplet previously. But this is a different one. So first we will define what is going on. Okay, so V the set of all real valued functions defined on R. R means here set of real numbers. The word is given on. The function is defined on R. The function is defined on R means domain set is also R and codomain is also R. This is called सहप्रांत. हिंदी में इसको बोलते हैं प्रांत. रेंज की बात नहीं कर रहा हूं मैं, परिसर की बात नहीं कर रहा हूं. डिफाइंड ऑन आर और डिफाइंड इन आर preposition means both the sets must be the same. Generally we say the function is from A to B. If it is from A to A, then we say it is defined on A or defined in A. So here it is this one. Now, you people are given this is domain is the set of real numbers. Codomain is also a set of real numbers. That means the value of the function is a real number. The value of the function is real number. That's why it is called real valued function. Because whatever the answer, this is the input. And this is the output. So here V be the set of all real valued functions defined on R. Examples. Fx may be e to the power x. Fx may be sin x. Fx may be x square minus 2x plus 3. Real valued functions. Fx may be cos x, etc. So what is V? V is the collection of all these functions. And if you know that, the algebra of functions, how to add two functions, I mean to say, this is the symbol for addition of two functions. So f plus c is given by fx plus gx. This is the property of addition of two functions. Remember, this is the point wise because this is a number. Fx, it is a real number. This g of x, it is a real number. So we people are doing nothing. We are doing sum of two real numbers only. In the similar manner, if c is constant and it is multiplied by the function, that means it is like this. What is f of x? A real number, because it is real valued function. So it is a real number. This real number is multiplied by this. This is also a real number. So product of two real numbers is a real number. But again you see fx is a function, gx is a function. So sum of two functions is another function. That means let us suppose it is phi of x, for example. Suppose one function is x square, other function is 2x plus 3. I mean to say fx is suppose x square and g of x is 2x plus 3, for example. Then what is f plus g of x? This is fx plus g of x, and this is x square plus 2x plus 3. Let us suppose this is phi of x. Say. Fx is x square, g of x is 2x plus 3. So sum of these two functions is given by this. Now the answer is again a function. And this function is defined on R again. That means the operation is closed. What is the name of the operation? That is addition of two functions. This is the standard addition of functions. In the similar manner, if I consider suppose the constant 2 of x, then it is 2 times of fx, and suppose fx is this 2 times of x square, then it is 2x square. Again, this is a function defined on R, that means R to R. Domain is not changed. The value is a real valued function. So this type of addition is the standard addition of functions, just like the standard addition in matrices, standard addition in polynomials, standard addition in ordered pair, triplet, and so on. Similarly, the scalar multiplication. So here addition is closed, scalar multiplication is also closed. Okay. Since the font-wise addition of two functions defined on the common domain is again a function with that domain. Therefore, addition of two function, therefore addition of two function is closed. Of functions is closed in the set of functions. We are talking about real valued functions, okay? Point-wise addition. Here it is. I am using this symbol particularly. It is just like alpha plus beta. So here alpha and beta be the members of V. So since V is the set of functions, so members will be the functions here. So I have used the symbol F and Z. So it is the sum of two members, and it is similarly. C is any constant. It is just like C alpha, so it is C of this, and it is defined by this one. Remember, it's better to write. Yes, we have used this symbol for scalar multiplication. So it is as usual as the odd number. Scalar multiplication is also closed because this is also closed. The result is on the same problem. Okay. So the point-wise addition of the two functions defined on this with the with the common domain must be the same for both. So you remember, if I consider the function is y equals to x square, the domain is R, all values minus R to R. And second, I consider suppose it is log x, then log x is not defined on R completely, because we people know that the domain of log x in real number system, that is positive values. That means greater than 0. So if we define log x, then x must be greater than 0. So the domain is not common with respect to this. So whenever you say domain must be common for all those functions, I took y equals to x square or sin x or e to the power x or cos x, the domain being the set of real numbers, that means from minus infinity to plus infinity. Okay. You can say the graphically also. Suppose I consider fx equals to x square and gx equals to, suppose I say minus x, for example. Then f is from R to R and g is also from R to R. Y equals to x square is the parabola and this is y equals to minus x. That means it will be this line. This is y equals to minus x. G of x is minus x and here it is fx equals to x square. Suppose I consider one point here. Let us suppose I am interested in this particular number 1, that is the domain value, that is the input. Then you can say here it is and here it is. Okay, so this is f of 1 and this is your this is 1 comma f of 1. It's better to write like this, and this is 1 comma z of 1. It will be this. So if we add, then the answer will be f of x plus g of x. Now here you have, so this is f of 1 g of 1. And what is f of 1 is 1. And g of 1 is minus 1. So the answer is 0. It will be this. Okay, now if we add these two functions, this is x square minus x. This is another function, that is phi of x. So here phi is from R to R such that phi of x is x square minus x. What will happen? The beautiful answer, you can say, if I put 1, then 1 minus 1 is 0. Find this. But if you draw the graph of this is the parabola, and its vertex is at 1 by 2 vertex. This is 2x minus 1. So if I differentiate it, then it is a 2x and this is x equals to 0. 2x, the difference is 2x minus 1. So x equals to 1 by 2. So the tangent is at this place here. Somewhere else it is. So if we find it is 1 comma 0, then we find this type of situation. Okay? Yes. So this is point-wise addition. Similarly, I'm using not the ordinary plus, but this is the standard one. This can be dropped with respect to this. Number 2 is square multiplication, so this goes. Always remember the sign is not kept here, but this is this also. Just like matrix is multiplied by the constant, and here two matrices are added. You can prove the associativity. Third, that is X. It is understood, so I write like this. Commutativity. Must remember means okay, so this is the function value. Fifth, there exists a function f naught belongs to V such that there exists a function f naught belongs to V such that f naught is operated with f equals to f. The answer is the function itself. That means it is like this. You need to know that f naught x plus fx equals to fx f naught x equals to fx. Then f naught is the identity. But you remember, we must have for this identity f naught, the answer is 0. Okay? This is the additive identity. Remember, this is the functional value, so this is a number, that is the real number here. You can say this, f naught x. So the image of all x with respect to that function is 0. So this element which is denoted by f naught, but the image set under this is 0, that means a scalar, so that is the identity element. In the similar way, you can find the inverse also. Then all other properties. So in the similar manner, we find the properties of, or you can verify the properties, that is with respect to the scalar multiplication. So if V be the set of all real value functions defined on R with the standard operations, then this V will be a function. Now we come to this question particularly. This is given, but this condition is also given. Satisfy f of 0 equals to 1. That means you have to choose those functions which are satisfied by this condition. Okay, so let us see. This type of questions we have done in matrices and triplet also. So now we come to this. Let fx equals to e to the power x and g of x equals to cos x. F of 0 equals to e to the power 0 is 1. Condition is satisfied. Similarly, g of 0 equals to cos of 0, that is 1. So condition is satisfied. Let us check the closure property. Fx it's okay. Let us verify this first. This is f of 1 g of 1. And what is f of 1? Remember here this is the point-wise addition, so this is converted into the ordinary plus, okay? Because this is a real number. Remember. F of, is 0, 0. So this is 1 plus 1, that is 2. Since we people know that this is the function, so according to this definition, the functional value at 0 must be 1, but here we people are getting 2. That means this is not equal to 1. Therefore, is not closed. At very first step, it is failed. So if some condition is given, then you must look at that condition. So you have to choose that member which is satisfied by the condition. So one counter example is sufficient here. If it is closed, then we must have this property. Then it is just like this. Here it will be this. Then it is 2. Then answer must be 1 according to that, but it is not. So this is not closed. Now come to the second part. Let V be the set of all real valued functions defined on R as usual, but here plus is as usual. That means addition is the standard addition of functions. Here it is given. Ordinary addition, you will see in here, because this is a number, so it is sum of two numbers. And define the scalar multiplication. This is not the standard one. The scalar multiplication, the standard one is c is multiplied by this, but here you can see x is increased by c, so it is f of x plus c. So use this scalar multiplication and determine V is a vector space or not. Okay? Now today I am giving you the homework on vector space. So you just look at the board. There are 3 questions you can say. First one, these 2 elements will be given, the set is given. Determine whether the set with the standard component wise operations is a vector space. It is already explained what is the standard or regular addition and regular scalar multiplication, or sometimes it is said component wise, first component to first, second to second, third to third, and so on. Okay, so this is the first one. Second, let S be the set of all vectors in R cubed such that x plus y minus z equals to 0 and 2x minus 3y plus 2z equals to 0. Remember, this is satisfied by this one. So be careful, and it is in R cubed. That means it is in 3 dimensions. Sometimes you can write in terms of coordinates, that is x comma y comma z. So with the standard component wise operations is a vector space. This is given in the column matrix. Maybe it is in terms of triplet, that is x comma y comma z. In the similar manner here, maybe in terms of triplet. Okay, so it is this type of situation. Third one, the set way is given. Again, this is a column matrix, but there will be two members. One is cos t, another is sin t. T belongs to R, that is set of real numbers, and define. This is the addition. Remember, in these two questions, you people are given standard addition and standard scalar multiplication, but here the addition is defined in different way. Suppose it is not given, and if it is given component wise, then what will happen? We add just components, that means first to first, second to second. So we write cos t1 plus cos t2, sin t1 plus sin t2. But remember, it is not given in the definition. If people are given, this is a special type of addition. So be careful. Yesterday it was explained. In the similar manner, the multiplication is given. This k is not multiplied by this term. The k is multiplied by the angle. This is given in the question. So in this question particularly, the definition of addition and scalar multiplication are changed. So you just apply this definition and find out the additive identity and additive inverse, and you have to show that V is a vector space. Okay, so all the best. You just try all these 3 questions and write comments in the comment box. If you have difficulty, then ask me. Thank you very much.